Hello, everybody, and welcome. My name is Heli Helskyaho. People know me in Twitter as Heli from Finland, and in many other cases as well. So, Heli from Finland. Today, we talk about automated machine learning and machine learning services. So, these are the services for those people who want to take it easier or who would like to get involved with machine learning with some background knowledge, but not enough to be a master in machine learning. Very briefly about me. So I have graduated from University of Helsinki and currently working on my doctoral studies. I've been working with Oracle products since 1993, and therefore my examples here are from the Oracle world. I have been working with data and databases throughout my career, so anything to do with data and databases is very interesting to me, and therefore machine learning is something very exciting. I'm a CEO for Miracle Finland, Oracle Ace Director, and I have been listed as one of the top 100 influencers on IT sector in Finland for quite many years. I'm a public speaker and author. I have written 3 books, currently working on my 4th book, and already plans for the 5th one. These are my books that are already available about database designing, about SQL and PL SQL, and also about machine learning. So the process of machine learning is seen quite complex because it needs so many different kind of skill sets. So people kind of are afraid of starting with machine learning because of that fact. So here's an example of a process. First of all, you define the task and understand what the task is about. So the task could be like find the top 5 breweries in Finland, or find the customers who are about to leave my company before they leave so that I can contact them. So defining the business need that can be solved or helped by machine learning. Then collect the data and understand that data. Collecting the data can be very time consuming and quite difficult. And it is possible that the data that you have collected doesn't really answer the question you have in the task. So it is possible you will go back here and you will find more data to be able to answer the question. Then we have attributes, features, columns that are about the data, that are describing the data, like age of the person, salary, address, this kind of things are features. Size of a house, and so on. Preparing the data and transforming the data in a way that the algorithms understand it is also some work. You know, we have null values. The scale of the data is maybe too broad or whatever. So there's a lot of things you need to do to the data to prepare it for a machine learning process. A simple example, maybe the data type is wrong, so that the algorithm can't use it in a correct way. Then you create the model. First of all, you define what kind of model it will be. It will be a classification model. And then you select the algorithms that you want to use for creating the model. So after you have created the model, you need to evaluate it. How did it do? So you train it and you test it. So how did my model perform? And which of these models that I created is the best for my purpose? So this is a big task. Then you score and you maybe deploy to production. And deploying can also be a kind of a task for you to perform. So a shortcut for this might be maybe AutoML, which means that you have automated quite many of the steps in a process, or maybe AI services. And these are the things we talk about today. So AutoML, in Oracle, you can find AutoML here in the Oracle machine learning screen. It's part of that. So let's see how it works. We will do a demo on AutoML. Let's see. The Oracle machine learning is able to do a lot of things. You can use notebooks, you can use AutoML, and many other things. In the autonomous database, it supports both SQL and Python. In this example, we will see how AutoML works, because AutoML is the tool for somebody who wants to use machine learning easily. AutoML is based on Python. So there are special Oracle functions and procedures that we are going to use here, or libraries. So it all starts with creating an AutoML experiment. So let's create one. You have to give a name to your experiment. So let's say this is student experiment. Surprisingly difficult to write student. The first step is to choose the data source. In our example, we will use student trained data. In our example, we are trying to predict which of our students are going to enroll the class. Based on what I chose here, what we are going to predict, based on the data type of this, it defines the prediction type. The available types here are regression and classification. But since this here is a text type, a classification type of entity, categories, enroll will not enroll, it will choose here classification. Case ID means that I will choose here what is the primary key of each row in my table or my data set. So what's the identifying column? So this is not mandatory, as you can see, but in my example, I do have a student ID for my data set. I also have additional settings. So I can define here how many models do I want to see here, how many top models that the process finds will be shown. What's the maximum run duration for this training the model? What service level are we going to use? The available service levels are low, medium, and high. I'm going to use medium. What is the model metric that I want to use when creating the model? So how will it define what are the best 5 models? I will choose balanced accuracy. Then I can see all the algorithms that are available for classification in my database. So I can either choose all of them, like I will do, or I can select or deselect some of these algorithms. I want to use all of them. Then I can see all the features. So these are the columns of the table. I can see of each of these how many, first of all, what's the type, the data type of this column. So it's number here. I might see some that has the wrong data type for machine learning and I have to go and fix it somehow. I can see percent nulls. If I have a lot of nulls, I might want to do something with those nulls because they have no value in my process. So I might to delete them or add some values based on some kind of logic. How many distinct values each of my columns have? What's the minimum and what's the maximum value of each of these columns? Of course, this is only shown for those that are number. What's the mean and what's the standard deviation for my numeric columns? So this is where I can check what data I have. I might realize that some of these columns is something, or these features is something I don't want to use, so I can deselect it. But in this case, I will just keep everything. Then I can just start my process. There's 2 ways of running this experiment, either with faster results or with better accuracy. In the sake of the time here, I'm going to use the fast version, and we will see what will happen, what happened here. So first of all, it starts. It's preparing the running of this process. It's first doing initialization, which is now done, and then it's going to algorithm selection, adaptive sampling, feature selection, model tuning, and it's doing the model tuning for each of my algorithms. And then the last, it will do also feature prediction impact. So it will show me here where it's going. So it's algorithm selection, adaptive sampling, feature selection, and now we are going to model tuning, and it's doing the tuning for each of my models automatically. And when it's done, it will show me here support vector machine, linear. It has built a model called like this, and the balanced accuracy for this model is here. And it's doing the same for all of my algorithms, all the algorithms I chose. I can already see that my data was not very good, as often happens. So the data does not have answer to my question, but then I have to do something with my data. I need to add something or find better data, more useful data, whatever. But this is an easy way to see if I do have the answer in my data set. So slowly we are building all those models using each algorithm. So here it tells what algorithm is used to build what model with what balanced accuracy. So this is the metric that you chose when you started the experiment. I chose balanced accuracy. And also the same time when it's building that, it's collecting information about the features. So how important are these features for predicting enrolled? Surprisingly, first name is very important compared to others, which is of course nonsense. First name has no impact, I know that, but the computer doesn't. So already based on this, I can be quite sure that my data doesn't have the answer. So there is not enough data that would tell if the person is going to enroll or not. I would have seen it already when I started if I were experienced in machine learning. So I would have already noticed that this data does not include such information that would have any kind of impact on the enrolled feature. Credits, gender, name, age, these will not affect if the person will enroll or not. But since I know nothing about machine learning, I just gave the data to the computer and I'm asking, find me out if this is something that could be useful. So it's running 2 minutes now, and we are quite far already. We are doing the last model here, and then moving to feature prediction impact. When the whole thing is done, it will show me here that it's completed, but let's wait patiently until that. But as you can see, this is easy. Not much you have to know about machine learning because the computer is doing all for you. All you have to know is what are you going to do with machine learning? What is your task here? So my task was to find which of my students are going to enroll to the class. So it's now completed in 3 minutes, so quite fast. Now I can see here all my models. I can see the importance of each of my feature for prediction. If I choose here one model, I can rename it. I can deploy it very easily. I can create a notebook based on this model. Or I can add additional metrics to define which of these is the best. I don't go to details in metrics here, but the metrics depend on if you chose classification or regression, because both of those has different kind of metrics available. So based on these, I can now compare. If these are very close to each other, I can see which one is better in something else. So I can have several possible things available, metrics available. Something I can also do is if I select my model, I can see the prediction impact. So how did each of these feature impact to this particular model? And I can also see a thing called confusion matrix. So how well it predicted truth and false. So actual 0 was predicted to 0, 53%. Actual 0 was predicted to 1, 14, 31. Actual 1 was predicted to 0 too many times, I think, and actual 1 was predicted to 1 not enough times. So this is what I can see from the confusion matrix. And it depends on which of these models you choose. You can see the same kind of thing from that particular model. So using all this kind of information that you can see here, you can choose what is the best model for your purpose. In my case, none of them are good enough, so I need to keep working on the data. But this gives you good tools for working on machine learning without really knowing too much about it. I will just show you one more thing. If I go to AutoML again, I can choose it from the menu as well. I can create one model with another kind of data. So if I have here house data, and I'm going to predict the price of the house. See, now it's number, and my regression type is my prediction type is regression. So because this one is number, this one is regression. So if it chooses the wrong one here for your purpose, it's because you have a wrong data type for that data set. So this is how AutoML works. It's quite simple, quite easy, and it gives you the full functionality of machine learning for two things, classification and regression. What happens here, if we check the model we just created, students experiment. So if you want to, let's take this one. If you want to create a notebook based on this, you can see exactly what we have here. So now we have student experiment NN. If you go and see notebooks, we have here student experiment NN. And from here you can see that what actually the AutoML is doing, it's using Python. So you will have a full notebook of what happened during the machine learning process. So this could be used as a way of learning how machine learning works. Because by just clicking what I did there, I created a notebook that has all necessary things. So I have the import, I have all the columns chosen, what is needed for the machine learning process. I have a trained data set built. I have all kind of things done automatically here by the process. So it is a good way to learn also how machine learning works in Python. I hope you understood how AutoML works. Well, this was a quick demo about it. So that was AutoML very briefly. So now you hopefully understand what is AutoML about. The next thing we were planning to talk about today is AI services. So AI services are pre-trained models for a special use case, for a certain use case. And you can use those pre-trained models with your own data to solve those kind of issues or tasks for machine learning. This is how it looks like. Let's quickly take a look in real life how it works. This is how the OCI looks like. And from the main menu, the navigation menu, you can find Analytics and AI. This includes all kinds of actions or functionalities that are related to analytics and AI. As you can see, there's plenty of those. Now we will talk about AI services that you can find from here. So AI services at the moment include language, speech, vision, anomaly detection, and digital assistant. This is an area that is a growing area because people want to use machine learning easily. Easily means that you have pre-trained models that you can call with your own data. So you don't have to do the whole process of machine learning, starting from scratch, from training the model and so on. You can just use pre-trained models for a certain purpose with your own data. In these examples, you can do language detection, different kind of things from written text. You can do all kind of AI functionalities from speech or from images or from videos. You can find anomalies from the data, or you can build digital assistants using these services. So the idea of the service is to make your life a lot easier in the world of machine learning and artificial intelligence. So these are functionalities for somebody to start using machine learning easily, but they are only for certain purposes. So the model can do something particular and it cannot be used for something else. Okay, so that's how it looks like in the OCI. So how do these AI services work? Let's start with language. We're not going through all these possible solutions. We just see some examples so that you can get an understanding how they work. So language can be found from here. Language has pre-trained models for language detection, named entity recognition, text classification, sentiment analysis, and key phrase extraction. And in this brief demo, we will take a look what that actually means. Let's see the language service. So if I select language service, first of all, I can take an overview. So what is this service doing? Or I can go straight to text analytics. So in text analytics, I first see what are the prerequisites that I have to meet first. So I have to give some policies or create policies, which means I need to give privileges to the users who are going to use this service. But that's something we will skip now. It's very simple. So the thing is that in the enter text to analyze, you can just write here any text that you want to analyze and you just press analyze. And it will do a lot for your text. By the way, the service can be also used through a REST API. So this is not the only way to do it, but this is a very easy way to do it. So first of all, it's detecting what language are we talking about. So what is the language in this text? The language is English in a very, very high confidence. So it is quite confident that this is English. It can classify also what is this text about. It's about sports and games or motorsports. And also quite sure about this classification. The next thing it does for the text is named entity recognition. So it has certain named entities, categories of entities that it uses to find from the text. For example, Henry Ford is a person. Today is date time or date. Indy Autonomous Challenge is an event. A car is a product, and so on. So it finds different kind of entity categories from the text and classifies these words, like autonomous vehicles are a product. It also finds key phrases from the text, like in the Autonomous Challenge, OCI, Henry Ford, auto racing, taking place, and so on. And these can be used in the process of machine learning as a next step for something else you want to do. Also the sentiment analysis. So it says that this document seems to be quite positive, but not very confident about it. So these sentiment analysis can be quite difficult, even for human beings, to understand, especially if it has humor or sarcasm or something like that. It is quite hard to know if it's a positive or negative thing. But anyway, this is a model that tries to investigate what kind of sentiment does the document have. There was no aspect detected by the aspect-based sentiment, but the sentence level sentiment is analyzing that the first sentence seems to be neutral, the next one positive, then neutral, and then neutral. So quite easily you can do this kind of analysis of the text. If I write something here in Finnish, this is not easy. Okay, let's see what it thinks about this. It's quite fast, as you can see. It does recognize it's Finnish. This is very impressive to me because Finnish language is not very often known anywhere. But anyway, this model can understand even Finnish. It says that it's society and state, religion and belief, which is not true. What I wrote here is, this is an example of a Finnish text. I wrote it myself. So it definitely failed here, but it did recognize it as Finnish. Finnish language is very difficult for machine learning, so already good here. It didn't find any entities from my text. It found phrases. This I wrote. The sentiment here is neutral, which is, by the way, true. It was a neutral text, and it's based on these two sentence level sentiments, neural and neural. So this was a neural text. So very brief example how it can also recognize Finnish impressively. So that was a quick look to language service. I hope you got some kind of idea how it works. Another example I was thinking we will take a look is a vision service. So what is vision about? Vision has image classification, object detection, and document AI. Quite interesting service because it can be used for so many purposes as by itself, but also as a pre-processing for something else. Let's take a quick demo how it really works in the Oracle world. Vision is very interesting because it can be used for so many purposes. So vision in OCI includes three different things: image classification, object detection, and document AI. Let's start with image classification. So here we have an example of an image, and it's labeling this image overhead power line, transmission tower, plant, sky, and line. It also finds a text if there is text in the picture. This doesn't have any text. Another example here, we have a pair of jeans, and it will tell us that there's a pocket. These are jeans, denim, textile, and trousers. And raw text couldn't find anything. You can add your own pictures here very easily from the object storage or from local files. So I will choose from local files. So here's a picture of me presenting at the German user group some years ago. It will detect here that there's a human arm, human head, human face, clothing, and human body. It also detects that there is some text. There's word mirror, miracle, dollar sign, and euro sign, and dog. So it can detect many things from the picture. Labeling is very good thing here because now also this can be used for the next process in our machine learning on the next step in our machine learning process. So now we have labeled data about image, and we can use it for something else. Object detection is detecting different kind of objects from the picture. Like in this example, it's finding a bus, a car, another car, and so on. And you can also choose from here to see where's a person, where's a car, what is this car, and so on. So it will show you them from the picture. Or another picture, there's a helmet, there's a person, and there's a human face. Again, if it can find raw text, it will find that as well. Let's test with the same picture we did on the previous one. So what objects do we detect from this picture? First, the labels. We can find a person and another person. We can find a computer monitor. We can find footwear and another piece of footwear. See, it's highlighted here. So these footwears here, this person, and a computer monitor. It can also find the raw text. It found these texts from the picture. So quite useful. Something that is extremely useful too is document AI. So using the computer vision, it's reading the text in a document. So for example, here we have a receipt. So from the receipt, it's finding words. It's finding key values. And it's finding a table. Like here, a receipt has a table here. So the order lines or the receipt lines. And this is again very useful for the next process. Another example, a little bit more text here for the model to analyze. It will take a little while to analyze, of course. It will find the raw text, line and words. I can click here to see where is this particular information. Key values, no, not this time, but plenty of table. So it found the table here. And again, I can use this for the next process. Or I can download a searchable PDF. I can also build my custom models if that's needed. So that is a very interesting service that is available from the OCI. So that was a quick look to Vision AI service. Data labeling, as we saw there, it can automatically label your data. But it is also possible to do it manually using data labeling. That can be also found from analytics and AI, but under machine learning, not under AI services. So this is a manual labeling of the data. Why on earth do we want to label data? Because labeled data is needed in supervised learning. You can't train and test the model if you don't have labeled data. And labeling images, documents, and those complex objects can be a little bit difficult. So labeling is identifying properties, labels for images or text, and annotating or labeling them with those properties. You can have single label or you can have multiple labels. So let's take a quick demo about data labeling to make you more understanding about what this is about. So as we saw, vision is able to label images for us. Another way of doing labeling is under machine learning here, data labeling. So this is a way to manually label data sets. So under data sets, first of all, you need to choose your compartment. And secondly, create a data set. I have already some data sets here created. So let's say image classification, for example. So how it works is that you just add here data in your data set. And after that, you can label it. You can add more labels if you want. In my example, I have man and woman here. And I can select a picture and then label it. This one is a man. And this one is a woman. And so on. So this is how I can label my data very easily. So it all starts with creating a data set and then classifying those images. So that's about data labeling. What do we have else here? Anomaly detection is one of those AI services we have available in the OCI. Anomaly detection is for identifying rare events observations that are very different from the maturity of the data. Like here, we have data points in our graph, and one of those data points is very different from others. And we should be able to detect this particular data point. So anomaly detection has a multivariate anomaly detection in time series data, univariate anomaly detection, non-time series anomaly detection, so different kind of anomaly detections. All of these OCI services have some kind of prerequisites that you have to prepare before you are able to use them. You have to create policies, either to a group or a single user. I prefer granting the privileges, creating policies for a group. And then you need to grant access to the data itself. Anomaly detection is about data. It's about creating a project, creating a data set, creating and training a model, and detecting with new data sets using that model that you just created. So first of all, the data. So the training data should not include outliers because we use this data to train the normal situation. The training data should teach how the normal works, and it should teach it as well as possible. If you run into problems, it is either a problem with the data or the privileges. This is what I have learned when I've been using this service. So be sure that your data is correct and that you have the correct privileges to be able to use the service. So this is how it looks like. You start with creating a project. I have created here an anomaly detection project. The next step is that you create a data asset. So a data asset is created under the details page under the data assets by pressing create data asset. I define where to find the data. It can be in the Oracle Object Storage, or it could be in my database, or it could be in InfluxDB. So the data asset needs to be defined. What is the training data set that we are going to use to train the model? In this example here, I have selected from the object storage a bucket where I have the data. So I select the training data, which is a CSV file, by the way. And using that data, we can create and train a model. So this is the same details page where we went to data assets, and now we go to models and we press create and train a model. So we have to define the data asset we are going to use for training. Since I already defined the data asset, I can just choose an existing data asset, or here I could create a new data asset, but I wanted to do it as a separate step. So I have created a data asset, and using that training data asset, I'm going to build now a model. Here I define some parameters for it. There are not too many. There's only 2 parameters actually that I will define. And I make sure that everything is correct here before I press create. After creating, my model is in a status of creating. And when it's ready, it's available to be used. So now that I have the model created, trained, and even tested with the proper data, I can use any kind of data that has the same structure as the training data to detect anomalies from that data. So here in my model details page, I just say detect anomalies. I can define a file where I have my data. It can be a JSON or CSV file. And I say detect. By the way, all these services can be also used with REST APIs. And if you have more data, you should be using that and not dropping here a file. But I don't have a large data. I just have a small data set where I want to find the anomalies. So I will drop here the file and I will say detect, and it will detect me the anomalies. Depending what kind of data I have here, it will find different things. I can also see it as a JSON file. It is a very useful service for finding anomalies from your data. A little bit more complex thing is a digital assistant. So you also find it from AI services like we found the other services we used earlier. So digital assistant, Oracle Digital Assistant is called ODA. You can create a digital assistant instance from the OCI by selecting Create. This assistant instance can be a shape of development or production. So from the ODA instance, you can find a service console that you can press to find more functionalities. By the way, in OCI, everything has an OCID, which is an ID for whatever object you're working with. Also, these instances have their own OCID. This instance has a menu where you can select different kind of functionalities that you will be using while building, using, maintaining your digital assistants. There are core modules in that menu. There are skills, digital assistants, channels, and stores for deployment. Skill is an individual chatbot. It has multi-language functionalities. A digital assistant is a master bot that invokes these skills. Channels are messenger connectivity webhooks. And a store is a store for bots. So these ODA skills are using trained models to perform their job. They use messages that are interpreted by their trained model. The basic concepts in ODA skills is intents, resolved and mapped to a dialogue, to an utterances. Entities that are values that are extracted from a user's message. And then components, dialogue flows, and channels, and also instant apps. And there's also functionality Q&A. So this is how it looks like as core modules. So we have web, mobile, messenger, voice, for example, Alexa, and these are connecting through a channel to an intelligent routing, which will lead to digital assistant, to the correct skill, the correct bot that will help you. And these can be used with different other functionalities. So a new digital assistant can be created by selecting from the main menu Digital Assistant. You'd give it display name, a version, a platform that is used, and some other properties. Then you define skills by pressing New Skill. These skills will also have a display name that will be used in a catalog, and they have the official identifier for the skill as their name. They also have versions and platform versions. They have a primary language, and they have also possibility for other languages as well. They have intents. These intents could be like ask for the price. So kind of what are they trying to do? And they have utterances, those questions the user will be asking, like about the price. How much is it? Is it expensive? And so on. So what kind of utterances will be used potentially? And then we have entities like computer type. It could be a value list of different kind of computer types like non-professional use, professional use, super user, and so on. So when you build these, it's machine learning, so you need to validate, you need to train them. And it will show you here with this red spot that you need to train it. So it needs to be trained. Something has changed and you need to train it. Either you haven't done the first training or something has changed and you need to retrain it. Then you have a conversation designer that can be used to create those conversations. So you start with greeting, tell the description, tell the price, and so on. So what kind of conversations are you planning this bot will have? So there is a course available if you are interested about learning more about these ODAs. This is too complex to be explained in just one session. So this was just quick look what we are talking about. So these AI services we talked about, the vision just came out, speech is coming out, and there's a thing called forecasting that is probably coming out soon as well. So there's more and more AI services coming out because they are for a particular use case. They are not, you are not able to use them for everything. And therefore, we need to have separate services for different use cases. And there will be more coming out, depending on the use cases that are more popular in the field of machine learning and artificial intelligence. So today we talked about machine learning and how you could be using machine learning without any kind of panic. So it feels like it's a huge step to come to the machine learning area, but it is not. It is no need to panic because there are plenty of solutions that will make your life easier and the learning curve also easier. So don't be afraid of machine learning because there are tools for you. We talked about AutoML, which automates many steps of the machine learning process. You still need to define the task. So what are you going to do with machine learning? What is the business problem you're going to solve? You still need to find the data for it and somehow prepare the data so that it's usable for machine learning. The AutoML will do some functionalities for it as well. So somehow transforms the data for the algorithms as well. But it is always better that you prepare the data as well as you can. So you still need to do something for the AutoML, but it will automate many of the steps in the process. When the process is done and you have several models created, your job is still to define what metrics or matrices are important in your task. So how do you define which of the models is the best for your use case and your purpose, or is any of them good enough? And if it's not good enough, what do you do next? How do you solve the problem? So you still need to do something yourself, but many of the steps are automated and you don't have to worry about them. We also talked about AI services that are solutions for particular kind of problems. When the data is certain kind and you are trying to do something with the data. So there are pre-trained models for those problems, and you use those pre-trained models with your own data to solve your problems. Makes it much, much easier when you don't have to train the model yourself. We talked about some AI services, but there are definitely more to come. So different kind of problems can be solved using AI services also in the future. So I really encourage you to start with machine learning because it is not as bad as it sounds. So people think, because it does need a lot of different kind of skills. You need to understand the business, mathematics, statistics, all kind of different kind of things. So it sounds scary, but it is not, because we have a lot of tools that will help us. So really start with machine learning and start today, because you might like it. It is very exciting and very interesting. So really find some tools that you want to use and start learning machine learning and start using it as well. Thank you very much for attending. If you have any questions, I am happy to answer. You will reach me from email, Twitter, and you can read my blog. The blog is mainly now about database designing, and unfortunately, I've been too busy to write anything lately, but it still exists if you are interested. Thank you very much for attending, and any questions, happy to answer.